Hi. So you noticed when we were doing notes the other day about how it's kind of laborious or takes a long time or kind of tedious to write out all of these structural formulas. It gets kind of aggressive, especially as you start to increase the number of carbons. And there are lots of other ways that you can represent these molecules that are much shorter, that make your life a little bit easier. We're going to learn a handful of them right now and practice some of them as well. So the first one is called the condensed formula. In the condensed formula, I'm just going to use these are as examples. These are the notes from the other day. The condensed formula. In the condensed formula, guess what? You just get rid of all of the lines, and you kind of read it left to right. So there's no bonds in a condensed formula. You're just straight up writing it. So if I was reading this one starting here and looking at what, or seeing what I'm seeing, I would go and I'd notice that, oh, that says like CH3. And so you'd start there and call it, you have a CH3. And then the next one right here is CH2. And then the next one, reading it left to right, is also CH3. So that's the condensed formula. You're just taking out all the lines and writing out. It's still kind of aggressive. There's still a lot to do there. But that is one way that you can kind of shorten how you write these organic molecules out. So condensed formula just reads it left to right, okay? Basically left to right. So if I was looking, sometimes you can group the ones together in the middle. Sometimes it's pretty common actually. So if you look at butane here, you could see it's CH3 as you're reading it left to right. I'm going like this, CH3, CH2, CH2, CH3. So CH2, CH2. So you can actually even further shorten these by grouping the middle ones together. I don't know, it's not super common, but it certainly is a thing you could do. So you could also call this CH3, CH2, parentheses 2. Sometimes you'll see it like that. I mean, each one of these means the exact same thing, this one and that one. Again, in this class, I'll tell you which ones I want you to do, but that's another example of a way that you can kind of shorten things a little bit. In addition to having the condensed formula, you have what we call the line drawing. The line drawing gets rid of basically everything but the lines. And so the line drawing is every time you put your pencil down on the paper, that's a carbon. And every time you change angles, it's a carbon. So I'll draw a couple, it'll make more sense. So propane right here, I'm gonna put my pencil right there. That's one carbon, okay? And then I'm gonna draw a line to the next carbon. You don't need to have a dot there, here. Okay, already off to a bad start, I'm a bad teacher. Okay, here we go. Carbon 1, and then every time you change direction is carbon, another carbon, so carbon 2, and then carbon 3. So on each of these, let's get a better highlighter here. Oh no. Come on, you guys. Okay. Carbon there, carbon here, carbon there. And you're just taking out the H's and the C's really, and representing it there. So each, at the end of a line, here, at the end of each line, you have a CH3, and where a line intersects right here, you have a CH2. So there is your formula for it. Now, of course, you don't draw those things. I'm just showing you that's what it means. So you could do the exact same thing with butane below it. Don't need those dots. Oh, geez. Don't need those dots either. Okay. So for butane, literally, there's 4 carbons. 1, 2, 3, 4 carbons. That's it. It's that simple. If there are, so obviously that's the fastest one. It's the one that gives you the least amount of information. You have to kind of process some things in your brain, but that one is way, way faster than, even doing the condensed formula. For the one pentene here below it, it's 5 carbons. So again, when your pencil touches the paper, that's the first carbon. What is happening? Oh no, abort. All right, so 1, 2, 3, 4, 5 carbons like that. And it could be the other way. Also, this means the exact same thing. 1, 2, 3, 4, 5. Okay. I don't know why I did it that way, but it doesn't really matter. Oh, geez. Let's write it right. 1, 2, 3, 4, 5. That's 6. Okay, I need to do better. 1, 2, 3, 4, and 5. There we go. And you also have to account for this double bond here on the drawing. So to do that, guess what? You just draw another line, double bond, bam, it's done. Okay. So there is, again, that's probably the fastest way to draw things. And I'll do the last 2 here just to show you, or the last 3, I guess. So For hexene, 2-hexene, same situation, 1, 2, 3, 4, 5, 6. And then when you have the 6 carbons there, your carbon is, or your double bond is on the third, between the second and third carbon. So something like that. Doesn't matter if you draw your double bond up here like this, it does not. As long as it's between the second and third carbon, you're going to be golden, okay? I think most of the time you're going to see the double bond drawn here, kind of interior to the next spot where it turns down, but it doesn't matter either way. So for 3,5-octadiene, if I drew that, I'm going to need to have, why is this doing this? I'm going to need to have the 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. Well, I like it better on paper. It's too gross on the iPad. Anyway, now fill in your double bonds. So on the third carbon, 1, 2, 3 carbon there, and then also on the 5th carbon there. And now you got a double bonds. And then finally, if you have like a methyl pentane and you have these branches off, you can draw the branches off too. So 5 carbons for the backbone of this one, methyl pentane, 1, 2, 3, 4, and 5. And then off of that third carbon in the middle, I've got a group pointing out. Again, remember every line is at the end of every line is a CH3. So there's a CH3 at the end of that line. And here, since there are 3 lines intersecting, we only have one H. There's only one spot left for H's, which is this H right there. Okay, so it all works together, and that's the shortest way. And we're going to practice all ways, of course, and naming them and drawing them from the. Going in all directions. So you should be able to name from this. You should be able to name from this. You should be able to draw from this. And any one of them. So it's all kind of connected, but you have to be fluent in all of them so you understand how to draw some of these molecules. But there you go, a short primer on not only doing the condensed formula, which is still kind of wordy, but also the line drawing, which I think most people like the best. There we go. This has been super fun. Okay, we'll see you soon. Bye.